Good morning, folks, and thank you for joining American Farmland Trust today for the second session in our two-part series, Quantifying the Economic and Environmental Impacts of Sustainable Practices in Vineyards. My name is Addie Candide, and I serve as the Pacific Northwest Regional Director for AFT. For those of you who might have missed the first session in our series, AFT is a national nonprofit organization that works to save the land that sustains us by protecting farmland, promoting sound farming practices, and keeping farmers on the land. And this webinar series is a partnership between our California and Pacific Northwest teams, and it really speaks to the second and third legs of our mission. We firmly believe that agriculture has an important role to play in mitigating climate change, yet we know that if we don't consider the economic implications of farm management decisions, we'll never be successful in achieving widespread adoption of climate smart practices. So our goal with this series is to train agricultural service providers, like many of you, on how to help growers assess the economic and environmental impacts of sustainable ag practices in their vineyards. And we aim to demonstrate that there can be an economic and environmental gain from these practices. For those of you who are attending who might be farmers yourselves, we hope to inspire and encourage you so that you can do the same for others. So again, thank you for joining us in this work, and I'm pleased to turn it over to Courtney Nauman, who will be managing the logistics for today's event.
Great, thank you, Addie. I am the Ag Stewardship Program Manager here in the Pacific Northwest, and I'll be mostly in the background today, monitoring the chat for questions, keeping time, and then closing us out. We will be recording, and we'll be monitoring and integrating questions as we go along, so any of those feel free to put in the chat, and our presenters will get to them. I'm going to put a poll question into the chat here. We would love to see where everyone is coming from today, and I'll leave this open for a couple of minutes. We're hoping for 100% of people saying which of these categories they best represent. For anyone that's calling in, I don't think you can participate in this poll, but we're asking who of you all are researchers from universities, maybe consultants, nonprofits, growers, government agencies, etc. Nice. Okay, I think we have most of us here. Thanks, Ashley. Any last people? So I see a lot of growers here today, and then a couple of folks from government agencies, a couple people who do research, and then who are affiliated with the university. That's great. Okay, thanks so much. I'm going to end the poll here. Awesome. All right, so it is my pleasure to introduce our speakers today. Our first is Paul Lum. He is the AFT California Project Manager, and he is an expert in case study development and the author of the grower profile that we'll be hearing more about today. Paul's background includes experience as an irrigation specialist for Solano Irrigation District and past president of the Solano County Farm Bureau. He currently serves as Vice President of the Solano Resource Conservation District, the Secretary of the Board of Directors for the Solano Land Trust, and serves on the Solano Flood Control Advisory Committee. Paul has owned his own farm near Vacaville, California for over 30 years and has experience with a diversity of crops and an intimate knowledge of operational and financial decision-making for farmers. He graduated from the University of California, Davis, with a degree in plant science and agronomy. We also have Dr. Patty Skinkis today, professor and viticulture extension specialist at Oregon State University. Dr. Skinkis conducts applied research and provides outreach and education programs for the Oregon wine grape industry. Her research program seeks to understand causes and management of vine vigor, vine balance, and impacts on fruit composition and wine quality. Her research also includes work on yield, fine-tuning canopy management methods, sustainable viticulture production, and understanding factors that drive industry production decision-making. Patty develops educational programs and publications for the industry statewide, and also teaches undergraduate and graduate level viticulture courses at Oregon State University. Her efforts also expand beyond Oregon, as she's a member of the National Clean Plant Network, the Grapes Advisory Board, and an associate editor of the American Journal of Enology and Viticulture and Catalyst Journal, and is the president of the American Society for Enology and Viticulture this year. Again, as I said, for all of you who are listening in on this call, please feel free to put your questions into the chat as Paul and Patty present. And with that, I will kick it over to Paul. Thanks, everybody.
All right. Thank you, Courtney. Good morning, everybody. Our two-part webinar series is titled Quantifying the Economic and Environmental Impacts of Sustainable Practices in Wine Grapes. This session is our second webinar, of which the first webinar was held last Thursday. Here's the agenda. We are hosting these webinars to help you and the growers you work with learn about some of the farming practices that growers have adopted to improve soil health and vineyard floor management, and of the economic and environmental tools that you could use to assess the benefits of sustainable practices. To recap from last week, I spoke of our grower profiles and sustainability. Dan Rinke of Art and Science Agronomy spoke about soil ecology and no-till practices. And for the final session last week, I covered the cost-benefit T-chart methodology to estimate economic gains or losses from changes in farming practices. Today's talk will cover a couple of tools that you could use to assess environmental impacts from farm operations and from making changes in practices. I'll start off today with a description of AFT's grower profiles in wine grapes. And for those of you who sat in last week, thank you for your patience with the grower profile slides. The program is supported by the National Department of Food and Agriculture, USDA, through the Western Sustainable Ag Research and Educational Program. The goals and purpose for our webinars, grower profiles, and training sessions are to increase farmer adoption of practices that improve soil health and sustainability. Our focus is on providing tangible evidence of benefits from healthy soils through economic and environmental tools, publishing easy-to-read handouts describing a grower's success with soil health improvement, holding educational events and individual training sessions, and promoting the profiles to growers, the ag community, and the general public. Soil health. Why quantify soil health outcomes? There's scientific evidence that farming practices such as cover crops, nutrient management, and compost improve soil health and water quality. But there's not much information about the economic benefit, and farmers want to know the bottom line. AFT's California region published 2 California grape profiles, Mark Lyons of Ecoterreno Wines and Vineyards, and of Julie Nord from Nord Vineyards. These profiles were written by California staff of AFT, and although the profiles describe vineyard operations, we can write profiles for many different types of crops and farming operations. We recently completed a profile for Ken Kupperman of Jackson Family Wines in Yamhill County, Oregon. The profile of the Grand Moraine Winery Estate Vineyard will be published soon and available on the American Farmland Trust website. So here's the page 1 of that profile. Grower profiles in wine grapes are developed by assessing 5 healthy soils practices: nutrient management, conservation cover or planted cover crops, compost application, mulching of annual prunings, and minimum till or no-till. The grower profile consists of 3 elements: the grower story, the economic outcomes from adopting soil health practices, and the environmental outcomes, namely environmental impacts to water quality and greenhouse gas emissions. The story captures the grower's background in vineyard history, their approach to farming and stewardship, and any grower comments about their experiences with practices that they adopted. We quantify economic outcomes with a benefit cost analysis called the Level 3 T-chart. And the T-chart allows us to calculate increases in income from changes in farming practices or losses from changes in practices. And we quantify environmental impacts from adopting sustainable practices using USDA's nutrient tracking tool and USDA's Comet planner. For the Ken Kupperman profile, we interviewed Ken and learned of his farming background and the history of the vineyard. Ken told us about his farming philosophy towards sustainable farming and his involvement with wine grape organization research with the Oregon Wine Board and Oregon State University. He told us of his concerns in the vineyard, resource concerns with soil stability, erosion, and nutrient availability. Ken's sustainable practices since 2013 include minimizing tillage, cover cropping, nutrient management, establishing ecological compensation areas, and mulching. Ken says, my approach to sustainability is through whole farm management and being a steward of the land. On page 2 of the profiles, we include the cost benefit analysis through a T-chart. And this T-chart pictured is from the Ecoterreno wines profile. We listed cost reductions in practices and found an increase in net returns through improved soil health. And we discussed the T-chart analysis at our last webinar on the 18th, last Thursday. And we're going to email a link to the T-chart methodology after the webinar today. On page 3 of the profile, we describe the environmental benefits using the nutrient tracking tool and Comet planner. And so we'll talk about those tools later this morning. And for Ecoterreno, we were estimate the following benefits over a 7-year period since 2013. A 32% reduction in nitrogen losses. And I know you can't really read the narrative here, but those arrows are basically following the percentages here. 52% reduction in sediment losses and carbon sequestration equal to that of 760 acres of forests growing per year. The significance here is the reduction in nitrogen losses relates to a decrease in leaching to groundwater, greater nutrient cycling or availability, and the importance in the reduction of sediment loss results in improved soil stability and soil health. So how can ag professionals benefit from the grower profiles? The profiles could be used to demonstrate examples of grower success with improving soil health. We chose the tools because they're simple and easy to use, and we encourage you and the growers you work with to use them and try different scenarios to see what farming practices might be beneficial and feasible, or what practices might lead to cost increases. And ag professionals can inform the ag community, the general public, and the media of soil health benefits from practice adoption and of the tools we use to quantify those benefits. How can growers use the profiles? Growers can read about a fellow grower's experience with adopting healthy soils and sustainable practices. Growers can learn how to use the T-charts, nutrient tracking tool, and Comet planner to see what practices might benefit them. And growers could share the profiles and tools with their landowners, crop buyers, to improve communication and explore potential marketing opportunities. We are also collaborating with other agencies on soil health projects and staying connected with university extension, crop researchers, and nonprofits in both ag research and ag outreach in order to further our goals to scale up adoption of sustainable farming practices. Tips for writing a case study. To write a grower profile, I'll talk about the steps involved, including seeking growers, doing interviews, and using the quantitative tools. We look for a grower who is progressive-minded with their farming approach and who transitioned from conventional farming to sustainable farming. An example could be going from intensive tillage, for instance, 2015, to no tillage. So ideally, there would be several years of conventional practices and several years of current practice adoption. For some growers, that transition could be through purchasing a vineyard from a prior owner or taking over management of a vineyard and then changing practices by considering several years of conventional practices and then several years of sustainable practices. We can average out variables from weather conditions and the trial and error period that goes along with trying new practices. Growers should be willing to share their story and experiences, including the successes and challenges. Good record keeping is necessary and a willingness to put their story out there. The grower needs to be willing to share cost and return figures. And I found that recording the interviews is helpful to capture the discussion. And once we complete a draft, the grower could review and edit and approve of the profile. And I have found the total time for a grower, their commitment is usually half a day to 3/4 of a day. On to this one, this slide, using the T-chart, which we discussed last week, the nutrient tracking tool and Comet planner that we're going to discuss today. Use those as part of the grower profile. Shelby will describe Comet planner later this morning. And another tool option for climate impacts is the Comet farm tool, which is farm field specific and encompasses greater detail related to inputs. The findings are more accurate, but requires much more data entry and is more time consuming. So this concludes our grower profile session. We can now address Q&As, and afterwards, Dr. Patty Sinkus will talk about vineyard floor management. Try to get me back up here.
So if folks have any questions and want to put them in the chat on the side here, we'll take a couple minutes and wait for those to trickle in. If they don't, never fear, you can still put your questions into the side of the chat and then we can integrate them into the call as we go along. All right, Paul, I'm not seeing any come into the chat here, so you can move along, and if you see them come in, feel free to integrate them as you talk.
Great.
Okay, Courtney, are we ready to go with mine?
Yes, that would be great. Patty, go ahead.
All right. Well, thanks for the invitation to present some of my work on vineyard floor management today. I see a lot of familiar names on the list of participants, and I figured we probably would have mostly Pacific Northwest or Oregon growers or individuals who work with Oregon industry on this call. And what I want to share with you today is some of the work that I did on vineyard floor management a number of years ago. Actually, it was a 9-year study where we looked at essentially no-till within a vineyard setting in the North Willamette Valley. So I'm going to talk about that research today and entertain any questions that have to do with that. Now, the Willamette Valley is the primary area where I work for my research, my applied research, and we have 3 major classes of soils in this area. It's volcanic rock, sedimentary rock, or marine sediments. All of them are pretty much very well drained, deep soils that are either clay or silty clay loams. Oftentimes vineyards are on hillsides or base of hillsides. And this is important to keep in mind when we're thinking about healthy vineyard floor practices, because we want to make sure that the soil is staying where it needs to be. And on those hillsides, we can oftentimes worry about too much loss of soils into the waterways and not where it's meant to be on the farm. Of course, when I first came to Oregon, there was a lot of vineyards doing heavy tillage, and especially with new plantings, not really having enough cover on those hillsides, and it was really worrisome for maintaining good soil structure and not losing all of that soil. Also, when we're looking at the soils that we have in the Willamette Valley, we have pretty low pHs. And so here is a table of some soil analyses that were done as part of a different project where we have over 15 vineyard sites, and we looked at the soil pits in those sites and assessed the soil chemistry as well as their organic matter, and they have pretty low pHs, so between 5.2 and 6.6. Of course, the ones at the more 6 range have been amended with liming, and our organic matter is relatively high. It's usually between 2 and 5% depending on the vineyard. They have high water holding capacity, so we have the ability to maintain a lot of that moisture that we get during the growing season, about 40 to 42 inches per year. During the season, we could get about 20 inches of rain from April 1 to October 31st. Most of the soils have an effective rooting depth of 48 inches, but it could be anywhere from 36 to 72 inches. And most of our vineyards are dry farmed. With these types of soils, the high amount of rainfall and our high water holding capacity, it stands to reason why we have so much ability to dry farm these sites without supplemental irrigation, especially once they're established. Now, when it comes to vineyard floor management, a lot of the concerns around managing the vineyard floor is not just about keeping the soil where it needs to be or to help prevent weeds, but it's also about how to manage the vine vigor. One of our greatest production challenges in Willamette Valley and other areas of the state is just managing our vigor. And weeds, of course, can be a concern when we have so much rainfall and high soil moisture during the growing season. And of course, there's a lot of effort put into powdery mildew management. And certainly how the vines grow is related to how they're interacting with that soil sphere and the amount of soil moisture or vine nutrients available to the vine. We oftentimes get a lot of extra growth, and we're battling a lot of that due to just having extra laterals being grown, just high canopy density, and then that leads to low amount of sunlight infiltration, which then leads to more issues with either wine quality or just our disease management. Overall, these are very expensive practices to take care of, having to re-hedge, do leaf pulling, leaf or lateral removal, all of that adds more cost to the vineyard management. So when I first started working in Oregon, I thought one of the best ways we might be able to control vigor is through vineyard floor management. And specifically by doing sod or grass covers between the vine rows and really having a permanent structure there, a permanent vegetation there for year after year. So back in 2007, I started a project that looked at vineyard floor management. It really is not a cover crop trial because we did not plant various cover crops. We basically took the most standard practices that growers were using, either perennial grass cover, tillage during the season, or doing alternate row tillage, and evaluated those 3 treatments within a commercial vineyard. And we wondered if we could really control vegetative growth and vine balance by using a no-till system with that grass. And our hypothesis was that grass cover would be able to reduce vine growth through soil moisture competition compared to those alternate till or tilled systems. And so this is what the experiment looked like. This is early part of the growing season when we let the perennial grass grow. Prior to starting the study in spring of 2007, there had been a perennial red fescue stand planted 3 years prior in the alleys of this vineyard. And this vineyard was already 9 years old. Let's see. Yeah, about 9 years old when we started this project. So it was an established vineyard. And we did tillage in spring. So usually after bud break, we would go in and rototill between the vine rows. And then we would do that maybe 1 or 2 more times during the growing season. The alternate row basically had alternating rows of grass and tilled. And then the perennial grass was never tilled, and it was just allowed to grow and then was mowed during the growing season. For all of the tilled sections, they did have a winter annual cover crop sown in late season, so usually September before harvest. Something really inexpensive like oats was put down. It was not a legume type cover crop. And we did have undervine tillage or herbicide. It depended on the practices of the vineyard in a given year, but typically it was maintained free of weeds. Of course, there were times in the year like this in the picture when I took this that weeds were still growing there, but they were essentially not allowed to be wall-to-wall cover during the entire growing season. So this, like I mentioned, was a 9-year-old vineyard at the start of the project. It was 17 years old by the time we finished the project over that 9-year period. This was on Jory soils, so silty clay loam. There was no irrigation applied to this vineyard other than a small amount that was done by drip irrigation at the discretion of the vineyard manager, but it was a very small amount, and usually when we would do soil moisture measurements wouldn't even show up that we could detect it. So it was more of a feel-good application of irrigation. It was what they did across the entire vineyard. It was Pinot Noir 115 on 10114 rootstock. So we did collect a lot of data. Now my area of expertise is viticulture, so I've focused mainly on the plant growth and also the soil moisture. We looked at components of yield and fruitfulness. We looked at soil moisture down to 76 centimeters with capacitance probes positioned in the vine row. We did not do any measurements between the vine row due to tractor traffic and likely just having those access tubes being torn out. We did look at plant water stress, leaf chlorophyll. Leaf chlorophyll was to basically see, are we impacting nitrogen levels early in the season? We did look at bloom and veraison nutrient status. And of course, this project being done for a long period of time, we did look at fruit and wine composition. I'm not going to focus a lot on those today, but I'm going to focus more on the plant aspects. So essentially with this project, we were able to successfully reduce vine size by using a no-till system. So having the grass in the ground was able to reduce crop pruning weight and leaf areas within the first in the first year. So by the year 2, we were seeing reduced pruning weights. The shoot lengths early season were reduced by years 3 and 4. So it didn't happen overnight. It took some time. The leaf area was reduced by years 3 and 4, and it was by about between 20 and 40%. We did in fact impact yield by year 4, and that was because we had smaller cluster size. It was really interesting. We saw not only the canopies becoming smaller, the inflorescences themselves were smaller and typically had fewer berries. We did have an increase in yield to pruning weight ratio only 1 year. And this is important to note because basically we were watching the vines decrease not only their vine size, but their crop weight accordingly. So they didn't become out of balance. Most of what we were seeing, we believe, was driven by nitrogen interactions because we were seeing reduced tissue nitrogen by year 3. So here's what year 3, in middle of summer, the grass treatment looked like. So when I said reducing canopy size, it wasn't getting super low vigor. This is a very healthy canopy still able to fill the canopy. And you can see a nice amount of sunlight coming through the canopy. This is about mid-morning in the middle of July. And if you look in the alleyways between, you can see more sunflex here than basically, if you look really way back here, you can see solid, this is where we have the tilled, and we basically have very few sunflex coming through. So here's the tilled treatment. I went further down that row. You can see less sunflex coming through, much more dense of the canopy, that's more laterals. There's the same amount of shoots per linear foot. So it's not that we adjusted that, it's just more thick canopy growth with the tilled. And so for the Willamette Valley, we find that reduction in canopy size to be very beneficial from a canopy management standpoint. By the time we got to years 5 and 7, we saw a further reduction. By bloom time, we had 19 to 39% lower leaf area of the grass, or the no-till, which is the black bars here, compared to the alternate and the till. Those two acted very similar to each other. And by the time we got to veraison, our total leaf area was also lower, so 21 to 45% lower. This is really helpful, not only from a standpoint of reducing the amount of canopy management passes, but also likely would help with efficacy of a spray program. So if you're going through and doing your sprays and you're on either calendar or a interval schedule with your sprays, you're probably going to get better coverage overall in the no-till versus the alternate and the tilled vines, just because they are much more dense. And so here's an example in our final year of the study in 2015, which was year 9. If you look closely, we can see the tilled in the back and the grass here in the foreground. And what I want you to pay attention to is the hedge height. So the vines in the tilled had already been hedged. They reached above that hedge zone, whereas the grass had not quite really needed to be hedged. And so that's showing that it didn't delay the development of the vines, it just reduced the amount of total growth during the growing season, which again helps with reduction in canopy management costs. So during this time period, we did reduce vine size with the grass or no-till treatment. But one of the things we looked at, I mentioned, was the soil moisture. Now the soil moisture surprisingly did not vary drastically between the 3 different vineyard floor management practices. Even though we had all of the soil under the vine managed the same, so there was not any more or less weeds in any one of those. But one thing I want to show here is this is every year of the study, the volumetric soil moisture from bloom to harvest or near harvest. And our soil moisture values remained pretty high, so between 20 and 45% was our range. When we got to bunch closure, that was usually about one of the lowest time points in the season, so that would be late July, early August. We're getting to our lowest amount of soil moisture, and then we level out. One of our driest years was 2008. Some of our wettest years were 2013 and 2011, and we looked in each one of these years to see how the vines were responding to that soil moisture, because sometimes it might have been that we thought the soil moisture would be much lower if we have a grass cover there, and we did not necessarily see that as the case. So here's a breakout of some years. Here's 2007, the first year of the study on the left. There's basically no difference at any date, whether we had grass, alternate, or tilled. In 2008, I mentioned in the last slide that the lowest soil moisture of any of the seasons, we did see a difference in soil moisture, but only at the last date, the latest date near harvest. Now, the interesting thing is we do see that the grass tended to be actually higher soil moisture than the alternate or the tilled. And we believe this may be because the grass was not actively growing during the middle part of the season when our vines were demanding the most water. They basically went quiescent or dormant and weren't actively taking up any soil moisture, but acted like a living mulch to maintain or prevent soil evaporation of water that otherwise we would have happening in the alternate or tilled system. So that might be why we see slightly higher grass or in the vine row of the grass treatment having more soil moisture. There are no differences, however, at most dates and most years to suggest that our vineyard floor practices have very little impact on our soil moisture under vine. Now here's a wet year in 2011. We found that at the lowest soil depths, we really had no impact on our soil moisture, or at least no differences with our tilling treatments. But at the 18-inch depth, we did have some differences, and it was consistent for all of the dates, and where tilled had higher soil moisture and grass had lower. We believe this was the case in 2011 at these higher soil depth because the grass was still green through most of the summer. But we also had pretty high soil moisture. We never got below 25% volumetric water content for the jewelry soils, which would be considered ample water there for much of the season. And of course, especially in our highest demand being in around the August time period, we are not even below 30 in any of those in 2011. So it was not a concern. We did monitor plant water stress as well through stem water potential, and basically we found no differences in plant water status at any time point or any year. This is likely because the vines had already adapted to the soil situation they were growing under, and so we didn't see temporal shifts in the amount of stress that they were receiving. There were also, we typically didn't even get to a point that would be considered water stress, whereby you would want to add supplemental water. So we were at most at 10 bars, or negative 10 megapascals here for, or negative 1.0 megapascals, or negative 10 bars for the 2008 season was when we had the driest conditions and then the most water stress. But in most cases, if Californians saw this data, they'd say, well, we wouldn't worry at all for irrigation. What was really driving the bus in terms of reducing vine vigor is the nitrogen status. We saw already by year 2 that we had reduced the petiole nitrogen by having a grass cover in there. This was sustained through most of, or every year of the study, except for 2015, where grass had the lowest amount of petiole nitrogen in spring. Alternate was right in the middle, and tilled had the highest. So we're tilling in the vegetation that grew in winter in the tilled, and it's probably adding more nitrogen, and it's also cycling nitrogen that is able to be used by the vine rather than by the grass cover that is there, and that's likely what was leading to a lower amount of nitrogen in those no-till vines. We also found that by, I should back up and just point out the gray bar here is referring to the point at which it's considered deficient in Oregon for petioles at bloom. And for many of the years, the grass, their no-till treatment was actually at a level of deficiency, which is interesting because the vines still looked healthy and were doing fine. So that's where you have to kind of look at the perspective of what's actually going on in the vineyard and not just the critical values of the nutrient test. So these are the leaf blade nitrogen data from the 9-year period. We actually didn't start doing these until 2009, so 2 years after we started the project. Here we see that grass again was always lower at leaf blade with leaf blade nitrogen for every year of the study than the tilled or the alternate. And it usually was above the deficiency range. So it was only 1 year in 2012 where it dropped below that. And of course, not only did the vines not have a lot of nitrogen, we saw that the impact from the no-till was that the fruit also had lower nitrogen. And the optimum value here is in the red dotted line. Basically, since year 2 of the study, we saw that grass or the no-till treatment did have lower YANs. So the yeast assimilable nitrogen, and then the alternate and the tilled also had higher YAN values. But it's interesting, later years of the study, they actually all dropped. And I believe this has to do with some of the vineyard management practices that were going on outside of our study, where they basically started doing vineyard floor management a bit less, basically putting in less, doing less tillage under vine, doing less herbicide under vine in these last 2 years. So basically, we were still growing a healthy canopy, but we were starting to get low YANs, and that would mean that it would either need supplementation in the winery, or you could just go with what you have. And we did make wines in all of these years, and we found that we did not have stuck fermentations when we were at these levels. And these YAN values, I should mention, are from berries being pressed right away. They're not from must. So they'll come back as a little bit lower than what you might expect from taking a must sample. Also, one of the things we noted was that when we looked at fruitfulness, so early spring, when we're looking at the number of inflorescences per shoot, we did see a reduction in the number of inflorescences and the size of the inflorescences, but that didn't occur until year 4. So we do see that vegetative growth is being impacted in the no-till systems earlier than yield is, and yield was reduced, but it was never to a point that was concerning for the producer because they would do crop thinning anyway. So it was meeting their target yields at that time. So vineyard floor management from this study, this long-term study, we basically found that it was a useful tool. Using grass cover and not tilling it in was a useful tool to reduce vine vigor, especially in a high vigor vineyard. We did not see that the impact was due to soil moisture, but it was rather due to having nitrogen, reduced nitrogen status. So likely the competition from the grasses or other vegetation that came in, because we didn't reseed the grass, we just let it have its natural shift with other weeds coming in over time. And also the amount of nitrogen that was available through tillage probably boost the amount of nitrogen available and increase that canopy size in the tilled system. It is possible that you can do no-till without additional irrigation inputs, and likely also without too much more nitrogen input either, because our vines were not considered super low vigor. They were probably what I'd consider moderate vigor range once we got to a point where they kind of started to level out. And with that smaller vine size, we really believe that it helped manage water stress, because then it didn't grow as big of a canopy in the no-till system that allowed it to handle the late season water stress. Now it's on 101.14. This project was on 101.14 rootstock, which some have concerns that they have late season crashes when we have a water deficit or hot temperatures. And so we think that was fundamentally helping those vines perform well under those situations late season. We did find that although these vines produce fruit with low yan, they tended to have improved wine color and aroma. So we didn't necessarily feel like we would want to go back in and do tillage to compromise these other factors that were being impacted by the no-till system. And we published some of that work in 2018. If you're interested, I'm happy to share that with you. So the study findings, I wrapped up that project about 5 years ago, and those findings are really starting to be resurfaced as being helpful as people are starting to do less tillage and also no herbicide. Now that project was not done without, with a wall-to-wall cover, but it certainly would be interesting to explore how long we could maintain a wall-to-wall cover and how we might tweak our management practices in those situations to not stress the vines out too much, whether it's for water or nitrogen. Certainly our most common practice across the valley is alternate tillage, so having annually tilling one alley and then maintaining a grass cover in another. And I know some states do this differently, or some regions do this differently, but typically these aren't flopping. Typically they're the same tilled rows and they're the same grass rows here in Oregon. I still think this is going to be the way most people feel comfortable moving forward, but I think certainly from the results of our work, we have more people feeling confident that they can do a cover crop or a 100% vegetation in the alleyways year in and year out. And also, I just want to clarify, a lot of times people are talking about no-till, and I believe that no-till doesn't mean never till. So this is an example of a vineyard that I was working in with grape red blotch disease. This vineyard had been dry farmed. It was planted in 2000. The vines were relatively healthy, but they were showing a lot of symptoms of red blotch in 2018, which was one of our driest years in recent history. This is the day of harvest. We were harvesting our research plots, and we had greater concerns about this vineyard, and I talked to the vineyard management company and said, well, you might want to consider just doing some tillage, because they had not done any tillage between the vine rows, had not reintroduced any sort of new seeding for cover crop. It basically was grasses and whatever was allowed to grow for quite a few years. And so they went in spring of spring of 2019, did alternate row tillage, reseeded a cover crop, and this is what the vines looked like that following season, right on the same day of harvest, basically. You know, this was partly due to having more soil moisture available, more rainfall, but basically there was almost no symptoms of red blotch disease in this vineyard, likely due to just improving the amount of nutrients available to those plants during the 2019 growing season. So hopefully the take-home message I'd like to send people away with today is that, you know, the way you do your vineyard floor management, you have to find the right balance for your vineyard and your goals. How much tillage you do, or how much or what type of vegetation you use really will depend on your soil type, your vine age, ability for you to irrigate if you're in a dry region. So we're lucky we have plenty of soil moisture, and if we time our seeding properly in the Willamette Valley, we can grow just about anything. But I know that's not so easy in other parts of the state. So having that ability to even establish a cover crop is going to be critical. Also, considering what pests you have, both weeds, diseases, insects, vertebrate pests. We've been dealing with voles, and that's one of the issues that we are plagued with in the Willamette Valley. Not doing careful management of the vineyard floor vegetation can lead to a refuge for those voles, and they've been able to girdle vines. So that's a concern. So there's not a one-size-fits-all method for all vineyards, and just keeping in mind your opportunities to change the way you do things is most important, and never stop learning what the possibilities are. And that's it. Thank you. If we have time for questions, I'd be happy to entertain them.
Great. And it does look like a couple questions came into the chat, Patty, so I can offer them to you. The first is, what type of soil moisture sensors were used?
So we used AquaPro sensors. They're actually produced out of California. They're affordable. They're a capacitance probe. So they basically have tubes that you put in the ground, and you use that to, whenever you want to, take the measurements, and you can take them at any depth you want along that probe length. But it's AquaPro, AQUAPRO. I did have to do calibration curves on those to be able to fit those with our soil type. So that's just one caveat. If somebody wants to use those and come up with the same numbers that I have, that looks different.
Thank you. And then, was there a common nutrition program across all treatments?
Yes, the common nutrition program was no fertilizers. Basically, the only thing they applied was the typical thing that growers apply in the Willamette Valley, is between 1/2 to 1 pound of boron per acre across 2 applications before bloom. So basically, foliar boron was the only thing that was applied during those years.
Thank you. Did you notice that the grass aided in breaking up soil compaction, and did you test for that?
Great question. We did not test for that. But one of the things I can say is that, you know, they're driving tractors through those vineyards all the time. We typically would make sure our soil moisture probes were out of the way of the wheel well. And certainly, it's harder to work in the wheel well. We didn't want to drill in the wheel well to put this probe in, but certainly there is more compaction in that zone. And we did do one soil pit at year 3, and we did see less compaction in that zone. But our cover was pretty wide. It did actually, some vineyards, you know, the width of the cover is sometimes not as wide as the wheel well. It'll be pretty narrow. Ours was pretty wide, so it went even to the wheel well. Of course, that impacts the growth of the grass in those areas, but we had a pretty wide swath in the alley, and then the undervine was really only about 12 inches. It was a pretty narrow undervine width.
Great. Those are all the questions that are in the chat right now. If they start coming through again, we can offer them later. But thank you so much for that presentation. That was so interesting. And I'll kick it back over to Paul, I believe, for his next section.
Okay, yeah, navigating through here. Let me get my screen back. There we are. For this session, I'm going to talk about USDA's nutrient tracking tool. It's used to assess nitrogen, phosphorus, and sediment losses from farm practices. The purpose is to show that practices that improve soil health result in reductions in nutrient and sediment losses. And we hope that this instruction will help you evaluate how different farming practices affect soil and water quality, and ultimately provide you with an assessment tool that you can use or share with the growers that you work with. So shown is the home page for the nutrient tracking tool, and we're going to provide a link later. So NTT was developed to simulate farm management impacts to watersheds, farms, and fields. The model encompasses lands across the United States and incorporates national data for weather, groundwater, and for farm management, and inputs typical of those regions that are assessed. Here's a list of NRCS conservation practices evaluated by NTT nationwide. And I'll read off a few. I don't think you can see that very well. No-till across the U.S. would be also prescribed grazing, riparian areas, forestry, grass waterways, quite a few different conservation practices, many that are not within the crop vineyard or orchard, but surrounding part of the farm. Here is the data entry page. Note the presentation button on the bottom, and which provides links to tutorials and videos. So the first step is to create a field map based on either GPS coordinates or the site address. The shown is the Grand Moraine Vineyard, which consists of 35 acres. The next page shows the 3 soil types associated with the site, and the user can enter soil phosphorus in parts per million or from a soil test. Organic matter percentage is based on the soil type and typical farming practices. It's a default value. And then the soil characteristics for each soil throughout the profile consist of values for phosphorus in parts per million, bulk density, texture, organic matter content, and pH. So again, these figures are related to typical management before sustainable practices are adopted and related to the existing soil types. The next page are data entries for operations. So we selected Vineyards. The upper half of the page shows the scenario, and for Grand Moraine, it would be 2013, before healthy soils and sustainable practices were adopted. Intensive tillage was entered. Nitrogen fertilizer at a rate of 25 pounds an acre is entered. Approximate planting and harvest dates are entered. The vineyard is dryland farmed and receives a relatively high amount of rainfall. The lower half is the scenario for 2020 with cover crops planted annually, reduced nitrogen rates, minimum tillage, and harvest date, which has not changed. Note that if a blend of cover crops are seeded, it still counts as one cover crop, and you may have to select the predominant species in the mix. This page allows growers to enter other NRCS conservation practices implemented on the farm. So if there's a practice adopted outside the boundaries of the field, for instance, a grass waterway, wetland, be sure to confirm that the conservation acreage is not double counted with the field acreage. So for this example today, I left it blank. And here's the summary report after entering both scenarios. And this is page 1 of the report. And then we usually focus on the nitrogen, phosphorus, and sediment loss reduction, but there are other parameters that are assessed, such as surface flow off-site, and some others on the next page. Nitrogen loss reduction here is not a significant amount at a reduction of 6.6 pounds per acre, but the percentage reduction is 7%. And I presume that the high annual rainfall, relatively high soil organic matter content, and the minimal nitrogen fertilizers applied per acre factor into the relatively low nitrogen loss reduction. On page 2, look at the right blue arrow. Shown is sediment loss, which decreased from 78 tons per acre to 51 tons per acre, or a 27% reduction. Mostly attributable to cover cropping, I believe. It's a significant amount and basically indicates a decrease in erosion and a significant increase in soil stability. So we encourage you to play around with the inputs and different scenarios to see what's applicable for your farm or your grower's farm. And you'll find that the results vary between farms and areas, regions, is very dependent on soil types and the farmer's inputs. The tools methodology for determining nitrogen losses is quite a different approach versus a nitrogen management plan that is required to determine crop nitrogen requirements. We're promoting the tool to help growers better understand how soil health practices improve water quality, nutrient cycling, and reduce sediment loss. So we hope this is a useful resource that you can share with growers. Thanks for listening. And in the middle of the page is the link to the nutrient tracking tool. We now have time for questions and answers. And afterwards, Shelby will talk about Comet Planner.
Great. Thank you, Paul. Are there any questions related to NTT? I'll give it about a minute here. Okay. I'll let folks still put question. Oh, here we go. Our first question is, or it says, any good data on the effects of overseeding legumes into permanent sod to offset or reduce nitrogen competition? So I think it's, is there any good data on the effects of overseeding legumes into permanent sod to offset or reduce nitrogen competition?
I would like to kick that off to Patty. I don't really have any experience, with that type of data.
So there's likely not any, I don't know of a study that's been done in grapes on that. There could be, I just haven't seen that. More likely, there's been work with this in no-till vegetable production or row crop, where they've basically been trying to increase the amount of nitrogen by seeding in legumes. So it probably can work. It's a matter of how to make it work in the vineyard system.
Great, thank you, Patty. Okay, questions can keep coming in, but we will move along to our next section here. Our final presenter today is Dr. Shelby McClelland, AFT's climate change and soil health scientist, who will walk us through Comet Planner. Shelby recently received her PhD in ecology at Colorado State University, where her research focused on the ecology of natural climate solutions and how field-scale management decisions impact net greenhouse gas emissions through a combination of statistical, field research, and modeling approaches. Prior to being with AFT, she worked at a research analyst at the Environmental Defense Fund, researching enteric methane mitigation strategies and other opportunities to reduce agricultural greenhouse gas or GHG emissions. Shelby received her Bachelor of Science from Cornell University in International Agriculture and Rural Development.
Great. Thank you, Courtney, for that introduction. Sorry, I'm just trying to hide my screen here. Great. Yeah, thank you again to all of you as well for sticking with us through this final topic of today's webinar. So this morning, I will introduce the Comet Planner tool, which was developed by Colorado State University and USDA NRCS. Comet Planner can be used to estimate the greenhouse gas emissions, or greenhouse gas mitigation rather, and carbon sequestration potential of adopting NRCS conservation cropping practices. So during today's presentation, I will introduce the Comet Planner tool and describe the soil health practices that growers and technical providers can analyze for climate benefits at the county level. I will then spend a few minutes walking through the various steps and data entry requirements for using Comet Planner, focusing on a hypothetical vineyard scenario in the Willamette Valley. And finally, I will describe how to interpret the results of the tool. But first, what is carbon sequestration, and what are the major opportunities in agricultural soils to increase soil carbon and reduce both carbon dioxide and non-carbon dioxide trace gases like methane and nitrous oxide? So at its most fundamental level, carbon sequestration in agriculture is harnessing the power of plants to capture CO2 from the atmosphere during photosynthesis. Plants use CO2 to build carbohydrates in plant tissues. And some of this carbon is then released into the soil via root exudates, supporting soil microorganisms and the formation of soil organic matter. Plant roots, above ground plant tissues like leaves and stubble, as well as the carbon compounds released by plants and the organisms that rely on these plant-derived carbon compounds, all contribute to soil organic matter formation. Soil health and conservation cropping practices enhance the ability of plants to capture atmospheric carbon dioxide by increasing plant production, which allows this carbon to persist in the soil, drawing CO2 out of the air. Other practices that protect soils from disturbance, like no-till, can help decrease the release of carbon dioxide via microbial respiration back to the atmosphere. Many of these same soil health practices, like tillage, nutrient management, and cover cropping, can help to decrease the emissions of soil nitrous oxide emissions. U.S. agriculture is a leading source of soil nitrous oxide in the United States, and much of this potent greenhouse gas is generated through nutrient and soil management. And methane, or CH4, is another potent greenhouse gas, but the primary source in agriculture comes from ruminant livestock systems via enteric fermentation and manure handling. And it is not a major source of greenhouse gas emissions in cropping systems, with the exception of rice cultivation. So why use the Comet Planner tool? Comet Planner is an excellent way for anyone who is soil health curious to explore how the adoption of conservation cropping practices can impact on-farm greenhouse gas emissions. The tool allows users to evaluate the greenhouse gas benefits of 9 types of cropland soil health practices and 4 grazing soil health practices. The summary output provided at the end of the tool indicates the expected greenhouse gas benefits or trade-offs in emissions under the adoption of 1 or more soil health practices. And these results can really help growers and technical providers determine the appropriate soil health practices for their production context that helps to maximize climate benefits. So Comet Planner is a free and easy to use tool that is available to anyone with an internet connection. You do not need to create an account to use the tool, and the results provided at the end of the tool can be saved and downloaded for later viewing. Comet Planner should not be confused with the Comet Farm tool. While Comet Planner focuses on the carbon sequestration and greenhouse gas mitigation benefits of soil health practices at the county level, Comet Farm is a more detailed analysis tool that provides data at the field and whole farm scales. Planner is a critical first step in identifying soil health practices of interest, and it requires minimal data entry. While Comet Farm is useful for the valuation of specific farm-level soil health practice scenarios with more detailed climate benefit outputs, but it requires substantially more data input to use. While I will not present on Comet Farm today, if you are interested in learning more about this tool and its applicability, you can find a link to the Comet Farm website at the top of the Comet Planner website. So to use the Comet Planner tool, the first step is to create a project name and select your state and county. So in this scenario that we're going to look at today, I will be running Comet Planner for a hypothetical 50-acre vineyard in Yamhill County in Oregon. The second step is to select the class of conservation practices that you would like to evaluate in your scenario. Comet Planner allows the user to evaluate 5 different classes of conservation practices. The first class of conservation practices concerns cropland management. There are 9 conservation practice standards, or CPS, listed under this practice class. These range from the diversity of cropping rotation, like conservation crop rotations or cover crops, switching from intensive tillage to reduced till or no-till, nutrient management practices such as reducing synthetic nitrogen fertilizer application rates, or switching from synthetic to organic nitrogen sources. And it also includes other practices like strip cropping or mulching. The user also has the option to apply multiple conservation practices at the same time in their scenario. Briefly, I would like to demonstrate the other conservation practice classes and the CPS within them. So grazing lands contain 4 different CPS, including improved grazing and rangeland planting and nutrient management, as well as the ability to look at multiple practices together. The third conservation practice class, woody plantings, generally pertains to edge of field practices that growers might consider implementing. So with the exception of the first 2 CPS, which are alley cropping and multi-story cropping, many of these other practices can be applied to field borders, and they generally provide high climate benefits because they involve trees and shrubs. And these practices, we also know that they also provide other environmental co-benefits like improved water quality and wildlife habitat. But however, in Comet Planner, you can't actually evaluate those, but we know that these are important benefits that these practices do provide. Comet Planner also allows users to evaluate applying herbaceous cover directly to croplands or at edge of fields. And so similar to woody plantings, these practices often provide high climate benefits per acre while delivering other ecosystem services. Finally, while likely less applicable to this group, the tool also allows users to look at practices available for the restoration of disturbed lands. And note that 3 of these practices are specific to disturbed lands like mines and landslide areas. So in our scenario for a 50-acre vineyard in Yamhill County, we will select 4 conservation practices from the cropland management class under a 100% adoption scenario. So on this vineyard, we will adopt a legume cover crop that also coincides with a 50% reduction in fertilizer nitrogen. Second, we will evaluate the benefits of mulching the annual prunings from the vineyard and applying this mulch to the field. The third practice we will consider involves transitioning from intensive to reduced tillage. And finally, we will implement further fertilizer reductions by applying a nutrient management conservation practice for reducing nitrogen fertilizer application by 15%. So once we add all our conservation practices, Comet Planner will automatically generate the estimated carbon sequestration and greenhouse gas emissions reductions after we enter the acreage that we want to apply these practices to on the vineyard in step 4. And so again, for the simplicity of this scenario, we will apply each of these practices to all 50 acres. So in step 4, Comet Planner will automatically generate a breakdown of the expected climate benefits of implementing these practices over the entire 50 acres. So while slightly counterintuitive, positive values in this chart indicate a reduction in greenhouse gas emissions or increased soil carbon sequestration, whereas negative values in this chart indicate increased greenhouse gas emissions or a loss of soil carbon. So the first column generates soil carbon dioxide and carbon sequestration benefits. In our scenario here, mulching provides the greatest carbon dioxide benefits. The next column shows any changes to soil nitrous oxide emissions under these practices. And in this scenario, the only practice resulting in a change in nitrous oxide emissions was cover crops, where the addition of a legume slightly increased soil nitrous oxide emissions. The next column is for soil methane emissions, but these are generally estimated at 0 for these types of practices. And finally, the last column sums the net climate benefits of these conservation practices on a carbon dioxide equivalent basis. So in our scenario here, mulching provides the greatest climate benefits, followed by reduced tillage and cover cropping. So this tool is really straightforward and easy to use. It's not time consuming. I think it took me about 5 minutes or less to really pull this whole thing together. And so it's a really great way to quickly evaluate emissions reductions that you might expect from implementing soil health practices. And so our take-home point for growers and for technical providers is to try out the tool and to enter different practice options to compare the sequestration and greenhouse gas mitigation benefits that they might expect under their implementation. Comet Planner also allows the optionality of looking more closely at the emission reduction coefficients or the expected emission reductions per acre from a conservation practice at the county level. And if you're interested, I can spend some more time discussing these estimates and the methodology that's used to get to these estimates at the end of this presentation. However, most of us don't tend to think about climate benefits from soil health practices in terms of carbon dioxide equivalents, and it can be quite difficult to communicate the benefits of these practices using this terminology. And so the EPA's greenhouse gas equivalency calculator is a simple way to communicate these benefits and to easily understood and communicated metrics. The calculator is quite simple to use. You can take the final estimate from Comet Planner for your scenario and enter this value into the emissions calculator. The tool will automatically generate several different metrics to communicate carbon sequestration and greenhouse gas mitigation benefits. So from our example of 4 conservation practices on a 50-acre vineyard, total carbon dioxide equivalent benefits were 20 tons of carbon dioxide equivalents per year. And so this translates to the carbon sequestered by 331 tree seedlings grown for 10 years, or the carbon sequestered by 26 acres of US forests annually. A link to the tools and resources shared during today's webinar are included in this slide, and I am more than happy to drop these in the chat after this presentation. You can also reach out to any of the AFT presenters for more information about these tools. If you're interested in reading and learning more about AFT's grower profiles, please visit this link to view and download copies of these soil health case studies. So in summary, Comet Planner can help technical providers and growers quickly analyze the climate benefits of multiple soil health practices. And by using the tool, you're able to identify practices that you might want to consider under future adoption scenarios. And so when coupled with the EPA greenhouse gas equivalency calculator, Comet Planner is a powerful tool to inspire soil health practice adoption. So once again, thank you again for your attention during this presentation, and I would be more than happy to take any questions at this time.
Great. Shelby, it looks like there is one here in the chat, which is, what does NE mean?
I believe NE means not estimated. And I have to go back and look at that specific practice, but I think they didn't end up estimating, or there's no estimates available for that practice.
Great, thank you. Any other questions for Shelby to come through in the chat here? We are running a little early, so we might actually wrap up a little early. So any last questions for Shelby or our other presenters, I invite participants to put into our chat and we will work on answering them. Here's one from Patty. Is the EPA GHG equivalency calculator part of the Comet planner?
Great question, Patty. So no, it is not part of the Comet planner tool. So that would be a separate website you would need to go and visit to actually go and get that estimate.
I have a question for you. Can you talk about the limitations of Comet Planner? When wouldn't you use this tool?
Great question, Courtney. Yeah, so this tool is really great for planning purposes only, because these emissions reductions are estimated at the county level. So they're not going to give you really specific emissions reductions or carbon sequestration benefits that you might expect from these practices on your own farm. And so that's why going to Comet Planner is a much better way to actually get much better estimates with reduced uncertainty for your actual production scenario. However, quite data intensive to use. You need a lot of data, dating back the past 20 years of your management scenario or your actual on-farm management. And then if you want to actually evaluate a practice into the future, you need to have a little bit more information there, about the timing of certain management, like when you would do tillage or, when you do certain operations on your farm.
Great, thank you. Okay, I think we may wrap up there. Thank you so much, Shelby. So as I said, we're running a little bit early. I think we might wrap up. Oh, no, we have one more question. Who is currently using the tools the most?
That is a great question. I'm not sure who is necessarily utilizing it the most. I know I can just speak to AFT real briefly here with Comet Planner in particular. So our outgoing climate initiative director, Dr. Jennifer Moore, has actually taken the Comet Planner emissions reduction coefficients at the county level and combined those ERCs with the ag census data to be a really powerful data visualization tool to actually help folks more at the state, regional, or national scale actually do more large scale planning to help meet climate neutrality goals. So to actually, use the ag census data to see, where are cover crops currently being adopted in their state and what counties, and maybe, using that information further to explore, why does this county have particularly high adoption or particularly high number of acres under this conservation practice, and what lessons might we take from those counties to help neighboring counties increase their adoption. The tool, again, like with Comet Planner, it's another kind of, forward projection or future scenario analysis tool for states to kind of estimate, the upper threshold of greenhouse gas mitigation or carbon sequestration they can expect from these practices. And then going the step beyond that and thinking about, how might they incentivize these practices to be adopted, and then what kind of policy might need to be implemented to actually increase adoption. So AFT is certainly using the tool in that way. And then states, of course, have been using it to help look at their emissions from ag and really, emissions reductions they might expect really from implementing conservation practices.
Great. I'll open it up to our other presenters. Any closing messages before we officially close out?
Yeah, I have a comment partly related to the prior question and a little bit of what Shelby was talking about, the differences between Comet Farm and Comet Planner, and Shelby expressed that very well. Comet Planner is so straightforward that I think a lot of people, can use it without assistance, or use some of the existing tutorials. And, Shelby had referred to Comet Farm as much more detailed, much more comprehensive. And there are folks at USDA and possibly at AFT that could help growers and ag professionals use Comet Farm.
Great, thank you, Paul. Okay. So Paul, Patty, and Shelby, thank you so much. You presented really robust information on climate resiliency, case study development, and these tools. And hopefully everyone attending today and who is going to review this recording later has a greater understanding of how to integrate these features into case studies that they might develop or learn just from these tools in general. So there's 3 things that I'd like to close us out with. First, I put a link in the chat for a survey. I'm going to actually send it again so it doesn't get lost in our chat. We would love people to fill out the survey so that we can continue learning about how to best put these webinars on. The second thing is that I would love to highlight Oregon Climate Action Network's upcoming work, which is relevant to ours. OCAN will be hosting a farm planning for climate resilience, an Oregon Train the Trainer program in the summer and fall of this year. The train will advance the knowledge of farm-based solutions for climate resiliency and create a community of practice in Oregon designed to support grower transitions to practices that best store carbon and work for the farmer's bottom line. People interested in learning more can contact Ashley Rood, and I will put her contact information into the chat right now. And then lastly, a recording of this event will be published on AFT's YouTube channel for future reference. I'll follow up with resources and a recording link via email. And with that, thank you for all attending today and taking some time out of your morning to learn about these tools. And good luck in your part of stewarding the nation's most valuable soils. We really appreciate you. Thanks all.
Thank you.
Thank you.